Hi everyone. As Jamie mentioned, I'm Josh Simons from Arup in Brisbane. I'll use Angela's slide for our company background, I suppose. What Angela said for that. I'm just going to jump straight in because I don't want to keep you guys. So we did some acoustic modelling. It was more of there's a planning policy in place for a region within Australia. I can't actually say who it is. Unfortunately, it's a confidential client, so I'll refer to him as old mate for probably the rest of the presentation. So they had a planning policy in place with regards to commercial and industrial noise. And commercial was broken into two aspects where there was commercial noise from being like pubs, clubs, and then also from commercial noise in and around concerts. And we wanted to automate the current process, which was manual, where the guys they'd go out in the field, take their readings and their microphones, write that down on a piece of paper, transfer that to a spreadsheet, then transfer that into another spreadsheet to do their analysis. And it was kind of taking maybe a day to do kind of one reader count. And we also had so we've got a community engagement tool we call Collaborative Map, where we kind of put a web page up, people can put comments, and those fields are like, I'm happy with the noise, there's too much noise, and just kind of some free text comments in and around that as well. Our inputs for that, so we had the spreadsheet data, the guys had already had all the readings in. So we had multiple locations, which all had lat longs associated back to them. We also had the community survey results, which come out as a CSV file. And unfortunately, I don't know whose idea it was, but we were given a Google Earth KML file, which contained all the pubs and clubs and commercial, or licensed premises, I should say, which was, as if anyone's used KML, it's a bit of a dead end and very painful format to use. And we also had an Esri shape file, which had all the cadastral data. It's kind of not a very wide spread of input data, but a few mixed formats in there. So our initial plan was to do this awesome model. We were going to take all the octave bands and turn them into this digital elevation model for the whole of this area, which was around about 250 square kilometre area. And I ran it the first time just purely doing the octave bands, turning it into an elevation model, and I bricked my laptop. It died at a 43 gig DEM, which was just for one octave band, which is quite frustrating. So we kind of decided to ditch that idea because that was going to be our basis, and then we were going to add in things like buildings, vegetation, to kind of see what impact that would have on the noise readings. So unfortunately, that was kind of killed off quite early in the piece, and we wanted to kind of automate this. So that's actually the flow chart that the guys had, and that was quite literally, obviously handwritten, but actually you'd hand it round. So if I was doing some acoustic modelling, okay, cool. Here's our little cheat sheet, and you'd sit down with that and you'd work through it, and then someone else would need it, so, oh, here we go, pass it over. And that's actually a pretty decent scan of it, but the actual piece of paper is quite tattered as well. Because it was a bit of a bike, I suppose. Everyone had a go at it, so so the commercial testing side of things. So as I mentioned before, we had two levels of commercial testing. So for the indoor venues, or pubs and clubs, I suppose, we would use the L10 octave band. So that would be for any of the 8 octave bands as well. And if that was not greater than the L90. So to differentiate between the L10 and the L90, so the L10 is the octave limit for 10% of the time, so that's the maximum, and the L90 is the decibel reading for the remaining 90% of the time. So the indoor premises one would be the L10, so 10% of the time is not greater than the 90% of the time plus 8 decibels, which 8 decibels is not a huge amount, I suppose, but and the outdoor venues one we had was not to be greater than 65 decibels, which was quite interesting because one of the concerts that we took readings for, there was actually a guy who had a response back to the survey and said, the noise did not annoy me at all, but he actually had 120 decibels at his house. So it was quite significant, and he lived 3 blocks away from where the concert was as well, so it's quite a distance that it travelled. Because we couldn't actually do the DEM modeling like we were hoping to, because we were going to overlay the DEMs and then clip it on the cadaster and then kind of average whatever cells were within the cadaster and go, oh, well, that's your octave reading. We ended up using expression evaluators, and we've got the formula down the bottom there, which was just the distance logarithm and distance from the reader to the premises, and the distance from the respondent to the premises as well. So it was kind of a two-step process, and we had some duplicate filters in there to make sure that one pub was only getting one result back per respondent. So there's the final workbench, which is a bit of a mess. I'm semi-ashamed of it. It's kind of cool, but I'm also ashamed of it at the same time because there's not many comments there at all. And I've got a bit of a dumping ground. Ooh, I don't know whether I can. Oh, yeah, so down the bottom there, there's a bit of a dumping ground of an old transformer that we were trying to set up, and we were tweaking the formula that we were using. But yeah, there was a lot of to-ing and fro-ing, I suppose, out of this. And also the test filter kind of just down the bottom right there, where it's got a whole series of attribute creators after that. It was just seeing which one was greater than the next octave band, and then it'd work its way through all the 8 octave bands, and then an attribute creator out of that, which I'm sure there's a better way to do it, but I was a bit lazy at the time. So for the industrial testing was a really it's quite different from the commercial testing. So we would actually have a 140, a 200, and a 400 diameter circle that we would use around each of the premises. And then in there we would take the zoning information, so we would know that, okay, it's an industrial building and it's in an industrial area, it's fully surrounded by other industrial buildings. It was not as much of an issue if it was one industrial building in the middle of a retirement village. And the process for doing this, the guys had the same spreadsheet process, but they had, I don't know why, but they would export out the shape file into CAD, draw some circles in CAD, do some clips, get the areas back, and then somehow transfer that back into a shape file or into Arc. I don't know why it was that process, but that was what they thought was a good idea. I better not let them watch this video, but anyway. So this is the industrial testing that we set up. It's not quite as impressive as the other one. Still not annotated well, so best practices there. Yeah, we had all the spreadsheet readings coming in on the left there. And then we also did so the industrial testing had a whole kind of plethora of other tests we had to do, like background noise, background noise low, background noise high, which I'll explain in a little bit. But it's not a hugely complex workbench by any standard. It's a lot of just duplicate filter, testers, and expression evaluators. So this is the bit more detailed version of the industrial testing. So we had the zone levels for the survey respondents, and as I was saying before, it's 140 metres, not 120 metres. So we had influence factors. So the zone 3 and zone 2, one's residential and one's light commercial. And then we had that divided by 2, the area of the circle divided by 2, which I don't think I've got any annotated out. Okay, sorry. But within there, it was effectively the LEQ. Sorry, I should explain what the LEQ is. The LEQ is the average of the highest octave band as well. So the average score for that. So it would be the zone levels and then the DEM, which didn't really, unfortunately, work. So it was actually more of a mathematical equation back out. And it wasn't to be 3 decibels above the LEQ. I'm just trying to see. Sorry, I thought I put in an example, but I didn't. Sorry. But that whole process there, so the background noise limit is just effectively expression evaluators the whole way through. And then again, on the right-hand side, it's got a very simplistic tester with an attribute creator at the end of that. We also had I said on the commercial one, we had a thing that we called the sausager, which is probably not the best name for it, but it was effectively a bufferer that would use the offset according to the dissipation of the volume as well, or sorry, the decibels. So instead of having like a traditional buffer, it would just be 10 meters, happy days. That would actually be kind of dependent on what degradation you would have with the sound as it travels. So as it drops off quite significantly in the last 15%, maybe 20%, there'd be quite a short pullback on the buffering. And finally, conclusions. So I suppose because we were doing a back check on the planning, it was quite interesting because they initially went, oh yep, cool, we'll get you guys to do an assessment on how effective our planning scheme is, and we'll go from there. And then it was like, oh, but while you're there, why don't you do this extra modelling? Oh, well, while you're there, why don't you try this and try this method? And then they ended up spraying us with a whole heap of like, well, if you're getting these results, what about if we added or changed this value? So instead of being just to check what their planning study was, it ended up being a scoping almost for their next stage of their planning scheme. And the other part that was really, I suppose, frustrating was not being able to print out the FME Workbench easily. It was suggested at one point to make a Visio of the FME Workbench, which is redundant beyond belief. But it's quite frustrating because they're like, oh, well, yeah, can you just print it out? It's like, yeah, I'll print out an A1 slither and then have to print out another one and another one, and then join them all up in Paint. I didn't use Paint. I'm just saying you could use Paint. I used another high quality photo editing software for that. And the other one was they thought that FME was kind of a magic black box. You just throw data at it and you press run and then away you go, which was very frustrating to kind of get with. They'd go, oh, just hit run. It's like, yeah, it takes 4 hours to run. I can't just hit run and do other stuff. Yeah, desktop version was a bit frustrating with that. Cool. Questions? I think I'll probably blaze through that, so sorry. But yeah, anyone, any questions? Cool, it was comprehensive, awesome.